If you're watching this, you're probably very confused about list comprehension in Python. So you came to the right place. I will explain everything from the theoretical side, the very basics, to a bit more of the complicated side, where you get to work with dictionaries and so on. The important thing to remember with list comprehension is that it's effectively just a compressed version of a for loop. And the order it works is something like this, where you surround it in square brackets to make a list, and in the square brackets you have for every item inside the collection. This collection could be anything from another list or a dictionary. So you iterate through every item in the collection. If you want, you can add a condition, and obviously with an if you can also have an else, so it could be if else. I'll explain that later. And whatever gets passed in will go here as a result. So if the condition is true, or if there isn't a condition and you're doing everything in the list or everything in the collection over here, it will get passed in as in the results. And you can modify the results, so you can do results plus 2, for example. So let's say the result is 5, it would be 5 plus 2, that would be 7. And whatever the result is, it will get passed into the list over here. The important thing about list comprehension is they are very similar to generator expressions, and that's a topic for another video, but the syntax is very similar. You don't write these square brackets with generators. There's a few other differences as well. Generator expressions is also another compressed version of generators, which uses something called yield. That's a whole other thing. For this video, I'll be focusing on just list comprehensions. Now, you will also see 2 other examples. So just quickly over here, you have a list comprehension example, and you have 2 other examples, which is for loops and the lambdas. Now, this video isn't actually about lambdas or is it anything associated with lambdas, so maps, filters. I have videos on them, but they're mainly here to show you that A, there's other ways to do it, and B, if you're more comfortable with lambdas, you can use that as a reference point so you can understand list comprehension. But I won't be getting too into the lambda thing. Now, on screen and in the description, there will be timestamps, so feel free to click around, find the bit you're looking for. So for our first example here, we have a list of numbers and another list called squared. So what we want to do is get every number inside this list and square it. You can do that normally using a for loop by just, for every n in numbers, so for every item, every number in numbers, so it'd be 1. Then you pass it through 2, you pass it through 3, you pass it through, and so on. So for every n numbers, you add it into the squared list. And if you don't know this, how do you do squared? If it was just 1 asterisk, that would be times. 2 asterisks is squared. And then afterwards, you can print it out. As you can see, this very top one over here, you get 1, 4, 9, 16, 25. Doing it in a list comprehension way, you can see it's very similar. I say when you're looking at this comprehension, start from 4, not from n. You will see n for n. Don't look at it that way. Remember up here, the result is the end part of everything. It starts from the for loop, how it usually does, and the result is what gets passed into the list, and you can modify it at the very end from there. So in this case, we are starting from the 4. It works exactly the same. So for every n, every number, every item. So for every number inside this list of numbers, so for every item in this collection, we are passing it into the results. So this is what's going into the list. And we are modifying the results at the last second. We are squaring it. So that gets passed into the list where we are calling squared. And when we print it, we get the exact same answers. It works exactly the same with lambdas, but with lambdas, it's a one-off function, so you'll have to repeat it, which is why we use the map over here. We're just applying every function inside of this list called numbers, and we are sending it to something called squared. I explained that in a lot more detail in my map video. For the second example, this is a bit more complicated. This is if we're adding a conditional statement, which you saw over here. There's no else thing in this example here. But how it works is you have numbers, so 1 to 10, you have another list of numbers, and same thing, you iterate it through every number. This is just determining if it's odd or even. What this is for every number, so 1. So if 1 modulus 2, which is just if you get 1, you divide it by 2. If we just look at the remainder, so we're not looking at the, with numbers it's like 6.7, let's say. We're not looking at this 6, we're looking at everything past the dot. So if the remainder is not equal to 0, which is, it means it's odd. It means it's odd. And if it's odd, we just append it to the list and we print that out. And you can see we get this 13579. Over here works the exact same. It's almost as if we're getting this for loop and we're making it into just one line. We start from the 4 over here for every n in numbers. Exactly the same for every number in numbers. If it's odd, then you pass it in. If it's not odd, nothing happens because there's no else statement here. So only the ones that are odd get passed into this result section. Don't look at this as n because it might trip you up. Look at it as the result that's going into the list. This is the very final thing that you're sending right into the list. And we're not modifying it in this example, unlike what we did before. So the result is n, and that gets passed into a list called odd numbers. So the only ones that would get passed into it are the ones that meet this. If it doesn't meet this, it won't get passed into the result, so it will just get ignored. And this is the lambda example for that. So you might be having 2 questions right now. The first is, can you use else as part of it? The other one is, can you add in other data types? I'm going to show you how to do both. So here we have a list of strings. This list is called words, and we just have a bunch of stuff over here. We also have another list called results, which we're going to be printing out at the end. If you look over here, it's just one long text and it looks a bit confusing at a glance. The best way I think about it is, this is the exact same as this, except whereas this is nice and orderly, you go from top to bottom. Over here, you jump around quite a lot. So just to quickly work through the expanded version, for every word inside words, if the length of the word is bigger than 5, we would apply this method called dot upper. Dot upper, you don't really need to know this for list comprehension, but dot upper is just, it capitalizes every single word. This method, capitalize, only does the front word, the front letter. So apple is 5 letters long. 5 is not bigger than 5. If it was this, it will be equal to 5. This symbol means equal to or greater than. 5 is not bigger than 5. So you go to the else clause, see, you just move down and you just capitalize the first letter. So that's why you get over here just the capital A. And then you move on. Banana, that's bigger than 5. So you apply the word upper, the method upper, and you get all capital letters. And then you would go into the for loop again. So this time it would be cherry, after that it will be date, and then when that for loop's done, you print the result. So how does it change for this comprehension way? It works exactly the same, it's just the order, like I said before, is jumbled up. Remember how before you start from 4 and then you go into the result, which it looks like it starts at the first, but it's actually the final step. That's basically what this is. So you would start with 4, which in this case is way at the end. So for every word in words, so apple, no, that's the first thing we're starting off with. If apple is bigger than 5, so 1, 2, 3, 4, 5, it's not bigger than 5, so that's not true. We'll go to the else statement, which is right next to it, and we'll capitalize it. So only the first letter will be capital. But for something like banana, it works exactly the same. So every word in words, so this case banana, you pass it through, test it with this conditional statement. Now banana is bigger than 5, so we don't touch this else bit over here. We go left to the result section and we make everything uppercase and we pass it through. Then, the next one, cherry, date. So the end result of it is we'd have an entire list that has been passed through, either through the else part or through the normal result end. And we call it results, very creative, I know. And you get the exact same outcome. This is the lambda version. And in my opinion, it's even more confusing than the list comprehension, because really what the hell is going on here? Now, if you're all getting too confused about this, that's actually a good sign. List comprehension just shouldn't be dashed out everywhere. It's not superior to other methods like lambda or just a normal for loop. If it gets really confusing, if it gets too convoluted, at that point, scale it back. Readability is far better than just trying to make everything compressed into one line. I know you don't have to make this comprehension into one line. You can make it a bit more visually readable. But even then, a normal for loop, you work from top to bottom and everything is just very clearly laid out. But then you get to stuff like this and suddenly it's not completely unreadable, but it can get harder and harder. And you can imagine if you're applying dictionaries and objects and everything else all put together, you're just going to have a long string of text that makes COBOL look like English. So that's important to understand when to and when to not use list comprehension. Speaking of dictionaries, let me go on to example number 4, which is a very simple dictionary example. So if you don't know with dictionaries, when you iterate through a dictionary using a for loop, it automatically assigns it to the key. And what I mean by that is, if you look over here, I did person.keys, which is person, which is the dictionary, and you are just looking at every key. So name, age, city. You don't need the dot keys. It automatically assumes you are using the dot keys. Now there are others. So you could use dot value, dot items to get a bit more specific. That's going a bit more into the dictionary side of things rather than list comprehension. You can literally just do dot keys and then it gives you the context of, okay, we're only just dealing with the keys now. And it works pretty much like everything else. For every key inside this dictionary, so name, age, city, we are passing it through as a result. And we're storing that in this list called keys. For a bit more complicated example, here we have a dictionary called prices. So apple is a key with the price 5. Then banana 12, cherry 15, date 8. All of these are keys, all of these are values. And that's important to realize because in this commented section out here, I just put key of value. In this uncommented section, this is for contextual purposes, I put item price. So item, that would be apple, banana, cherry, date. Price will be the prices of those products, which should be 5, 12, 15, 8. So for every key value pair, I'm calling it items and prices. But you can, again, remember, you can just say key values if it makes it easy for you. So for every key value pair in the dictionary called prices, dot items. Items means you're using both keys and values. So what's happening here is you get apple, then 5, yeah? Items would mean you'd have apple in a string, obviously. And then you'd have 5. That's basically what this is doing. So for the first iteration, this is what you're dealing with when you call dot items. So if the value, which that's what I'm calling price, so if the value is bigger than 10, so is 5 bigger than 10? Because remember, that's the key, that's the value. I'm calling the value price. Is the price bigger than 10? No, it's not. So then you just pass through. There's no else statement, so you just go on to the next one. The next one being banana. And for banana, yes, it is bigger than 10. So you append the item, the key, to the list that we're calling results, and we are making it uppercase. So all of it's capitalized. Going back to the comprehension one, for every key value, so for every item and price in the list of dictionaries, we are getting, dot items. So remember how I said before, apple 5. And if that is bigger than 10, we pass it into the result section. If it's not bigger than 10, there is no else statements over here. So nothing happens. And then it repeats the for loop. So it will now go into banana. So if banana 12 in the prices, so that will be a tuple of banana 12. If the price, the value is bigger than 10, again, you go over here. If it's not, nothing happens. And the lambda function, it uses 2 of it. You need to first filter out and then apply to everything else. I feel like at this point, using lambda is just being a bit extra. You can even just use list comprehension. Like, that's not too unreadable. But if you do prefer to use lambda, that's the reference point there. So in the end, you would have banana and cherry inside the list, as those were the only ones with prices bigger than 10. And the last thing I want to mention, this part's commented out, is even though it's list comprehension, you can write it in a more readable way. So this right here is the exact same as this, but I just separated out. So the order's still the exact same. You start with the for loop over here, you go to the if, and then, you can work your way out from there. But I just want to show you this way so, you can make it more visually readable. But unlike the for loop, if you remember, it's not as straightforward. With the for loop, it's just, top to bottom. That's literally it. With this, you're still starting from the middle. And then you can imagine it if having an else statement, that'll make it a bit more, your eyes would have to move up and down quite a lot. But if you can see it vertically a bit better than you can horizontally, you can write this comprehension statement like this just fine. Now, that would be it for this video. However, obviously I didn't go through like literally every single thing, and that's because this comprehension is just a compressed version of for loops, more or less. And for loops are so fundamental. But regardless, hopefully this was helpful, and I'll see you in the next one.